2 weeks ago, we looked at techniques that we have to increase the internal validity of a study so that we can be able to say, hey, if we're providing cognitive behavioral therapy and we're measuring depression, we know that there's a link between cognitive behavioral therapy and depression and that there's not something else going on, like people are getting better or people are just growing out of it or whatever it is. And those mechanisms for increasing the internal validity of studies were the best mechanism we had was randomization. And the reason when I was explaining that, the reason that I suggested was that randomization creates random error rather than systematic error. Then last week, we talked about the same set of concepts, but applied to external validity through sampling. And again, our best technique was randomization, which allowed us to say that any differences between our sample and the population of interest were random differences, not systematic differences. And in both those cases, there is this idea that by using randomness to create either groups or samples, we minimize the risk that systematic bias will play in our study design and interfere with either internal validity of the study or external validity of the study. This week we're going to talk about another use of randomness, which is in the process of measurement and reducing systematic error, but recognizing that there's going to be random error in our measurement of any variables. And we're also going to talk about a different use of the term validity. The material for this week is also covered in chapters 8 and 9 of the textbook. And what I'm going to do is run you through a couple of concepts. First, we're going to talk about variables, what variables are, how we take a construct and operationalize it in terms of variables, and talk about some types of variables. And then we're going to talk about the difference between single item measurement and scale measurement. And then we're going to talk about the concepts of reliability and validity. Now, this concept of validity that we're talking about is not the same as the external or internal validity that we talked about with study designs and sampling. It's a different concept, but it's the validity of our measurement and the reliability of our measurement. So today, we're focused all on measurement. The first concept that I want to talk about in terms of measurement is operationalization. In the first couple of lectures, we talked about this idea of operationalization, that we have some set of constructs that we want to measure, and then for the purposes of the study, we operationalize them. I want to get into some more detail about this concept of operationalization. Operationalization of constructs to variables comes in many forms. I want to give you some examples. First, self-reports. Often what we do is we have something we want to know about a person. For example, their health status. How healthy are you right now? We could look at a number of things, but I could also just ask you, that's what a self-report is. How is your health? Is it good, fair, or poor? Now, by asking people, there's a set of problems that come with it. We're not always the best evaluators of ourselves, but often it really is an excellent measure of who we are because we can take into consideration a whole bunch of things that other questions might not be able to take into consideration. When asking about health, asking how somebody feels, how they evaluate their health is actually a very good and the best predictor of long-term health outcomes because people are pretty good about summing up how they feel. We can directly observe people as well. So if I want to know how good your health is, I can take your blood pressure. I can draw blood from you and put it into something or other that they use in the places that they draw blood from. We could also, I can measure your weight. I can directly observe all sorts of behavior from you. When we as social workers ask people who the president is, or we want to know what their birth date is, we're trying to use direct measurement of observed behaviors, orientation to self or place or time, in order to assess mental status. Sometimes we can just use existing records. If I want to know how your health is, I can go to your medical records. I can't actually access your medical records. But if one could access your medical records, they could go to your medical records and they could look to see, do you have diagnoses for a variety of different ailments? And so those are, whether I'm asking you questions through self-report, whether I'm directly observing behavior or health status, or whether I'm going to a set of records, all of these are ways that we take a concept like health and operationalize it to a set of questions that we can then analyze in quantitative studies. And one of the tasks you're assigned with is to critically appraise how the researchers move from concepts like health or depression or child abuse or sexual assault or whatever it is that we're investigating, and the variables that they use to measure those constructs. What is a variable? A variable is any observation that can take on multiple values. So if I'm interested in people's favorite color, I can just directly ask you through and have you self-report what's your favorite color, and then the attributes of that variable would be red, green, blue, purple, whatever the list of colors are that you're choosing from. So we have a variable asking you what your favorite color is, and then we have a set of attributes that populate that variable, and in this case it would be colors. So we have these things that are operationalized constructs. We call them variables. Those variables have attributes. Those attributes are things like colors or male, female, or your age, 25 or 38 or 45. So whatever the variable is, it has a set of attributes. We also put these variables to use, and we do that through identifying variables as either independent variables or dependent variables. Independent variables are variables that are used to explain another variable. They're the variable that we manipulate in an experimental context, or the variable that we think causes something else in an observational context, that we believe act on the dependent variable, which is the other major type of variable. The dependent variable is the variable that is affected by the independent variable. So if I'm doing an investigation of cognitive behavioral therapy on depression, cognitive behavioral therapy is my independent variable, the one that I'm manipulating and interested in. And what I think cognitive behavioral therapy does is reduce depression. And so depression is my dependent variable. It depends on the independent variable, in this case cognitive behavioral therapy. Sometimes the independent variable is called the predictor variable, and the dependent variable is called the outcome or the response variable. We also have other kinds of variables. We have extraneous variables that we're worried about affecting our understanding of the relationship between the independent and the dependent variable. And sometimes we just want to control or adjust for things. So sometimes in our statistical models, we'll say we're interested in cognitive behavioral therapy's effect on depression. And so we've got a variable, received cognitive behavioral therapy, didn't receive cognitive behavioral therapy. Those are the attributes of this cognitive behavioral therapy independent variable. We have a depression variable, which is a scale that we use, and we'll talk about what a scale is in more detail later. But we've got some way of measuring depression. But I'm also concerned because men and women don't have the same levels of depression. In the population, women tend to have higher depression scores than men. So I need to control or adjust my models to account for the fact that women are likely to have more depression than men. And so that gender, in this case, would be a control variable. I might also want to take into consideration income or race and ethnicity, or whether you've received cognitive behavioral therapy before, or whether you're on medication. Any of these other things that I think might affect the relationship between receiving cognitive behavioral therapy or not receiving cognitive behavioral therapy and depression are things that I want to either control for, or things that I find that are extraneous variables that I want to adjust my models for. The relationship between independent, dependent, and control variables can be seen in this diagram. In this model, the dependent variable, which is designated Y, would be something like would be our outcome of interest, like depression. The independent variable, identified as X, is the thing that causes a change in Y. So I believe cognitive behavioral therapy changes the levels of depression. I believe that getting supportive housing reduces use of emergency rooms. So there's an independent variable that I think causes some effect on the outcome of interest, the dependent variable. But there are things I need to control for. So maybe I need to control for where ambulances go in the case of supportive housing, in the example that I've used before. Or I need to control for gender in the case of cognitive behavioral therapy. And those are the Z variables identified here. And there can be as many Z variables in modern multivariate models as you need to, as you have the sample size for. So here is a model of how we are operationalizing our variables and our causal model. There are a variety of properties that our variables need to have. And there are a couple of really important ones that we're going to highlight here. First, the attributes of the variable have to be exhaustive of all the possibilities for that variable. So if I'm asking about gender, in a population where there are transgender or intersexed individuals, then just including male or female will not cover all of the possibilities of gender for the population of interest, and that creates a problem. If I'm covering age range, I can't leave off a particular age. If I'm interested in the role that ethnicity or race play in whatever outcome of interest I'm interested in, then I need to include all options, including people that don't identify as a single race or ethnicity. Sometimes people consider themselves interracial or consider themselves to have multiple racial or ethnic attributes. And I need to allow for an exhaustive set of attributes in order to include everyone. Now, often in studies, what we'll do is we'll just include an other category. So we'll say black, white, Hispanic, Asian, other. And so somebody that's from a native Hawaiian, for example, can say, well, I'm a native Hawaiian. Or somebody from the Middle East can identify as Arab, or whatever it is the person wants to include. So sometimes we'll leave an open answer in order to create that exhaustive list. Sometimes with gender, we have to think about how we want to do that, depending on the population. Another property of variables that's very important is that they are mutually exclusive, that categories don't overlap, because this introduces a form of nasty systematic bias in our study. So if I'm asking, for example, about age ranges, my age ranges need to reflect the exhaustive but mutually exclusive categories. So I can't say age 10 to 20, age 20 to 30, age 30 to 40, because in each of those examples there's an overlap. In the first example, it was 20 that was overlapped. In the second example, it was 30 that was overlapped. So the categories need to be exclusive and exhaustive. If you look at this picture over here, you can see an example from the parking garage right across from the School of Social Work, where whoever designed this clearly did not take this class, or took this class and did not get the concept of mutual exclusivity. Look at the hours.